Hi, this is Ron Mattino, and today we're gonna talk about Linux, an open-source operating system created by Linus Torvalds. This video is intended for people who pretty much know their way around Windows, but for some reason never had a chance to familiarize themselves with Unix-style operating systems or just starting to learn them. Today, I'm going to share with you some useful tips and tricks I've come up with for the past few years that will help you get started with Linux as fast as possible. Let's get going. So, to begin with, why would anyone want to use Linux? Well, firstly, Linux is free and will remain free. Windows isn't that expensive, but if you, for example, are up to setting up 10 mining computers, the price starts to matter. There are commercial releases of Linux too, by the way, but free ones are also fully functional and can be used by anyone. Secondly, Linux is highly configurable. It can be extremely lightweight. You can run it on very old systems if necessary and still get support both from the community and the developers. As we all know, with Windows, it's not possible. Linux runs on literally millions of devices, including servers, smartphones, development boards, smart TV boxes, and even supercomputers. So, if you manage to master it, you will greatly expand your horizons. All operating systems have something in common. Agree? That makes sense. But today, we will rather focus on differences than similarities. So let me ask you, what do we call an operating system version? Sounds like a silly question, right? With Windows, it's pretty straightforward. Every release, albeit based on the same kernel, is considered a separate version. For example, we have 5 versions of Windows 7. Windows 7 Starter, Windows 7 Home, Windows 7 Professional, and also Enterprise and Ultimate. But in fact, all of them is the same operating system, with some features enabled or disabled. Then we have Windows 10, which is basically a complete different operating system, but it is still okay if we say it's just another Windows version. With Linux, it's different. For one thing, the foundation of all Linux-based operating systems is the Linux kernel. A kernel is basically a memory-resident program at the core of an operating system, responsible for most low- and middle-level tasks. The Linux kernel is maintained by the community of developers, consisting of about 5,000 to 6,000 members. As the kernel is distributed in open-source form, anyone can use it to create a distribution for any purpose. For the time being, the most popular Linux distributions are Debian, Fedora, and Ubuntu. Then, every distribution also has its core developers, who, from time to time, post updates, bug fixes, and new versions. Every Linux version has a major build number and, optionally, a fancy name. For example, the latest Ubuntu is 20.04 LTS, and its name is Focal Fossa. Of course, there were Ubuntu 19, 18, and so on before it. And just like Windows, every Ubuntu version can come with some features enabled or disabled, and different software bundles pre-installed. But in Linux, these variations are not called versions. They are called builds. For example, the 2 most common Ubuntu builds are Ubuntu Server and Ubuntu Desktop. Contrary to what one may expect, the server build is actually the lighter one, because it has no graphics stack. It is intended for what it's called, to be run on a server and administered remotely. So it's basically command prompt only. No graphics interface, no windowing system. It's still multitasking, of course, and fully compatible with all Linux applications that do not require a graphics engine. The desktop build, on the other hand, is meant to be run on a user machine, and from that point of view, it looks and feels pretty much like Windows. So, this is the first thing you must remember. Server and desktop Linux distributions are not versions, they are builds. If you log onto any Linux community board and say, "Hey, I need help with Ubuntu server version," just don't do that. People are not gonna like it. Just kidding, seriously don't. If you want to familiarize yourself with Linux, you probably want the desktop build, because it has a graphics user interface, yet contains all the components that the server build has. However, if you choose server build, you can easily upgrade it to desktop later. So, how do you install Linux? For that, you will need a spare 16GB USB flash drive, a free utility called Rufus, and obviously the distribution ISO, which you can get off Ubuntu website. Now, here's the deal. You can pick any version, not necessarily the latest one. But software compatibility is more of an issue here than it is in Windows. And that's the reason there are so many Linux versions to choose from. So, if you're installing the OS for a particular purpose, say you plan to mine cryptocurrency or run a 3D renderer, or use any other proprietary software written for Linux, first thing you gotta do is find out which version you actually need so that it runs properly. If you're installing Linux just for fun and to learn things, you can pick any version. For this presentation, we're going to choose Ubuntu 20.04 LTS Desktop. By the way, LTS stands for long-term support, which means that in case you do not plan to upgrade to a newer major version, like 21 or 22, developers are intended to issue updates for this version for a reasonable amount of time, which means they got you covered. As you learn more Linux, you'll discover that the MS-DOS operating system, introduced almost 40 years ago, the one eventually evolved into Windows that we know today, carries some uncanny resemblances to Unix-style OSs. To be able to run text-style commands, in Windows we use something called command prompt, formerly known as DOSBox. For that purpose, Linux uses a command line interpreter called shell. One thing to note, however, there are several shell implementations around, and they are all a bit different. The most popular one probably is the Bourne shell, or Bash, written by Stephen Bourne of Bell Labs. If you're up to learning Linux internals, that's probably the one you'll be using most. Now, speaking of file system, here's your first big difference. Linux does not use Latin alphabet letters to enumerate drives, so there is no C drive there. Just like Windows, naturally, Linux has files and directories, but every path starts just with a / symbol without a drive letter. The slash is called root, and there is only one root directory in the system. So it appears as though your computer has only one hard drive, and all directories just reside there. In reality, it is possible, of course, to have multiple disk drives in the system, but instead of assigning individual letters, Linux just mounts them as directories that you can access from the root path. Isn't that a bit confusing? Well, if you think of it, it actually makes much more sense than drive letters. Remember the problems you had when you just moved a program folder from drive to drive? Well, in Linux, it's much easier. Obviously, it's also easier to merge several small drives into one. You can even replace the entire media if you wish, but as long as the mount directory name is intact, programs will run as usual. The shell command line operators are pretty much the same as in Windows. The cd command is used to change working directory, makedir to create a new directory. To list files, you use the ls command, that's Windows dir equivalent. To view file contents, the cat command, that's Windows type. To copy files, you enter cp, and clear clears the screen. This table lists most common Linux commands and their DOS counterparts. Linux, however, never had the 8-character limitation on file names. Tell you more, in Linux, file extensions are not mandatory. You can use the period character as much as you want. However, the 3-character part that follows, which we refer to as file extension in Windows, does not have any impact on how the operating system treats the file. So, how does the OS know if it's an executable? Well, Linux uses file attributes for that. We have attributes in Windows, right? Read-only, archive, directory, also an attribute actually that turns a file into a folder. Linux has them too, but in addition, it has the X attribute. This attribute forces the OS to treat the file as executable. So if you, for example, extract an archive that was for some reason created under Windows and it contains Linux executables, they will not run unless you set the X attribute explicitly. The command that does it, that's also something you really need to remember, is chmod +x filename. Batch files, which are called shell files in Linux, also require you to set this attribute in order to run. Shell files, funnily, often do use the sh extension, but again, it's just a tradition, not a necessity. Like I said, it does not mean anything to the operating system. Also, most other file types migrated from Windows, like JPEG, GIF, WAV, XLS, DOC, MP3, naturally have their regular extensions. But executable files never use the exe extension in Linux. They are just a file name without any extension. The shell usually highlights them to make them stand out. At the point when I was just starting to learn Linux, I made a mistake of renaming executables and adding the exe extension to them to make them look more familiar. Do not do that. Just get used to how things are in Linux. With time, you'll realize it actually makes more sense that way. There's another thing really different in Linux that always gets newbies confused. It's the current directory path. Let me explain. In Windows, we use the path variable to allow the operating system to locate needed executables. Linux uses exactly the same technique. However, the path to the current directory, the one you're in at the moment, is not included in that variable by default. Just think of it, current directory is also a path, but in Windows, we can run files without adding it to the path variable. It sort of just works while we're there. But in Linux it doesn't. So, to run a file from a current directory, you have to use this syntax, /filename. You can, however, add the slash path to the path variable, and it will work just like in Windows. But again, I strongly discourage you from doing that. You have to get used to how things are done in Linux without transforming it into Windows. Shell file scripting language in Linux is also different from what Windows uses in its batch files. It does carry some similarities, however, it's much more versatile and powerful, and Linux really makes great use of shell scripting. Important thing to note, however, if you're up to learning that language, you have to make sure you set the interpreter name right at the beginning of the shell file. The directive looks something like this. If you fail to do it, the shell file may not run properly, as the OS might pick the wrong command interpreter for it. Now, here's an important one that you really have to learn if you want to be Linux savvy. It's the file permissions. I'm sure there's an abundance of information on that on the internet, but I'll try to make it as short as possible. Like any modern operating system, Linux has user accounts, the list of people allowed to log in into system. Every user has a username and a password. On top of that, Linux also has user groups. Any user can be added to any group, and you can create as many groups as you want. But they are mostly used for administration purposes. Remember how old Nokia phones had the option to set ringtone for a group of users, and you had to create and populate those groups yourself? This is sort of similar. Now, in Linux, every single file in the system belongs to a certain user and a certain user group. That's called ownership. So, any file has a user ID and a group ID. IDs are usually assigned automatically at file creation time. Then, every file also has permission attributes, which allow or disallow read, write, and execute access to it. It's really straightforward. We mentioned the execute attribute already. Then there's read and write, which is pretty much self-explanatory. Now, here's the tricky part. In Linux, every file has 3 sets of these attributes. For the user, for the group, and for anybody, which makes it a total of 9. Each set gets applied based on who actually attempts to access the file. If it's the file owner, the owner attributes are used. If it's someone who is a member of a group the file belongs to, group attributes are used. If it's none of the above, anybody attributes are used. This, of course, is happening based on user ID and group ID of the given file. So, any file in Linux actually has 9 attribute bits, but only 3 of them are used at a time. Interestingly, these 9 bits are presented not in hex, but in octal form. For example, 777 means all 9 bits are set. And the changemod command that I mentioned earlier can also take this octal number as parameter. For example, changemod 0777 lecture doc will give full access to the lecture doc file to everyone on the computer. What good is it? Well, if you think of it, it's really versatile. For example, you created a document that you want everyone to see, but you don't want people to edit or delete it. So you set attributes to 644, which means owner can read and write, group can read, anybody can read. Or, if you want the file to be 100% confidential, you just set attributes to 600, meaning only you as the owner can read and write, while other users have no access whatsoever. Of course, it's possible to change user and group IDs for any file, if necessary. Linux also has a super user named root. Root has full access to any file on the system. Root access is used mostly for administration purposes. It's not really a good idea to log on and run the system as root, or allow applications to run as root, because that poses certain security risks. So, if you, for some reason, have messed up permissions for some file and lost access to it, you can log in as root and fix it, then re-log in with your regular username and password and continue. While in terminal, It is possible to run a single command with superuser privileges by adding a sudo prefix to it. That's a really convenient way of doing things as root without actually being logged in as root. In Linux, you'll be using that command a lot. When you do, the system will prompt for root password naturally. There's also a somewhat tricky SUID bit. I decided to tell you about it because it's also frequently used. If it is set, the file, when run, will use the permissions of the user who created it and not the user who is running it, as it usually happens. If the file was created by root, setting SUID can also pose a security threat because anyone would be able to run this file with root permissions and on part of that file perform tasks as root system-wide. And lastly, while we're on the file system subject, Linux has this really cool feature called symbolic links or symlinks. This is sort of similar to shortcuts in Windows, only Windows uses them for a different purpose. In Linux, on the other hand, they are a very important part of the system, and it pretty much depends on them. A symlink is basically a file that points to another file or folder on the system. Whatever manipulations are applied to a link are actually applied to the source file. Symlinks are not limited to a single drive, they can be created system-wide. To create a symlink, you use the ln command with the s parameter. The existence of the link file is optional. If it's absent, the system will create it for you using the source file name. There are basically two ways of installing software in Windows. The standard way is downloading the distributive and running it. The installation manager will then create all necessary directories, registry entries, copy the files over, and create desktop shortcuts. Alternatively, you can download the archive with the executables along with other files and directories, extract it to a folder of your choice, and run it. Expectedly, all of that also works in Linux. However, if you're up to downloading a program as archive, you need to realize that chances are the precompiled executable may fail to run on your system. A typical sign of that is the segmentation fault error message, which is roughly Windows program stopped working equivalent. Why so? Well, because of an open-source nature of Linux. There are too many compatibility issues to consider. Different kernel builds, different driver and library versions, different hardware platforms even, etc. When we see a Windows executable, we always know it's for the Intel platform, right? Might not be the case with Linux. Also, a program you download could be compiled by someone for their own custom distribution, which also makes it incompatible with your system. So, if you really need to run a particular program distributed in executable form, you will have to find the exact version and build of Linux that the person who created that file had on their computer at the time it was compiled and built. And if you ask me, is that always possible? My answer would be, unfortunately, no. However, there is yet another way of installing software in Linux. Most programs here are distributed in source code form and can be compiled by the end user locally. That assures the program actually will run on your system. In fact, the source code of the entire OS, including the kernel and drivers, is also available, and you can patch and recompile it too, if necessary. In reality, though, compiling a random program from source is not that straightforward, because you'd still need compatible libraries and the right version of the compiler. Because Linux is updated so often, your system might have newer compiler and newer libraries, which the build script might fail to recognize. But it's not as bad as it sounds. The good news is that most programmers supply step-by-step manuals on how to compile their programs. That is sort of Linux programmers etiquette. In case the manual is not present, you're gonna have to Google all your error messages or ask for help on Linux forums. The same goes if you need to use some proprietary device that requires a driver. For it to work, the driver must be supplied either as a precompiled module for a particular version and build, or in source code form, so that you could compile it into the kernel. That's just how things are in Linux. As opposed to Windows, however, Ubuntu Linux has a really advanced package installation tool, which can download software and updates automatically. It pulls them from dedicated online storage locations, which are called depositories. It's similar to Google Play or Apple App Store in a way, except it's all free. So, to download a program, all you need to know is its name. For example, I use a Norton Commander-style file manager for Linux called Midnight Commander. The correct package name for it is MC. So, the command to download and install it in Linux would be sudo apt install mc. It's done, and now we can run it by typing mc at the command prompt. Programs installed with the help of apt, which stands for Advanced Packaging Tool, already have their paths configured and can be invoked by the name of the executable. Just like Windows, Linux has standard directories where it keeps binary files. By the way, Midnight Commander also has a very nice text editor called mcedit, which is much better than the built-in Linux text editor. So, where did apt put Midnight Commander files? Well, usually Linux stores executables in directories called bin, but it may differ from version to version. To find the whereabouts of a particular program, we can use the whereis command. Whereis mc? User bin mc. And we can run it like that if you want. If you ask me about common directories in Linux, well, it's not as straightforward as in Windows, where you have program files, documents and settings, users, etc. But most common Linux directories are boot. This directory contains files needed to boot the system. For example, the grub bootloader and kernels are stored there. etc. contains configuration files, which are usually created by installation tools. Sometimes it might be necessary to edit them by hand. Bin. Placeholder for system-wide executables. Only the system and installation tools can use it. You should not put anything there. If you were to, it would require root access. Sbin. This is also meant for executable files, but mostly the ones used for administration purposes. Only root is intended to run them. You are not supposed to put anything here either. Var. Applications and system keep their log files there. Lib. Essential shared libraries. Libraries are installed by the apt. You should not need to edit anything here manually. Dev. Devices. Now, this is sort of a very important concept in all Unix-style operating systems. Devices in Linux are represented by files. For example, dev SDA is the first hard drive in your system. Note, however, that the dev SDA file is not file system representation of your drive, and you can't see directory listing by accessing it. If you were to run the cat dev SDA command, you'd see the binary dump of the hard drive, which I think is sort of cool. You can't do that in Windows so easily. Proc. This is analogous to dev in the sense that files here are virtual. This folder contains information on current running processes. This is sort of similar to Windows Task Manager. Lost plus found. Every Linux file system has this directory. It is populated during system crashes. Any corrupted files are put there, so you can attempt to recover them after reboot. Media. Now, here's the important one. Removable media like CD-ROMs, USB flash drives are automatically mounted there. User. This folder contains user binaries and read-only data. For example, user bin contains non-essential applications. The directory is still populated by installation tools and should not be used to store user-downloaded programs directly. Home. This is the place for user directories, similar to Windows users, and every user who has access to this computer has a folder in this directory. For example, if your system login is John Smith, then your user directory path would be home John Smith. Now, if you're new to Linux, here's something to remember. Your user directory is the only place where you're supposed to keep your stuff, including the executables. To store programs, you must use the home John Smith bin directory. If bin is not present within your home folder, create it. Do not use user bin, user local bin, or sbin for that. And last but not least, naturally, Linux has an abundance of really handy tools, but the following utilities will truly make your life easier. Top. This lists running processes in real time. Control-C to terminate. There is also Control-Z that just terminates program output. You should only use it if the program fails to respond to Control-C. By the way, unlike Windows command prompt, Linux terminal always echoes key presses, even if the program is running. That's a way to test if your connection is alive. Kill all. This is the command that you use to terminate a process and all of its children. Kill all accepts process name as parameter. Dmessage. This command dumps entire boot log to terminal window. This is used to troubleshoot boot or device initialization problems. You can use it together with the grep command that finds strings by the keyword, like this. Cron. Cron is a job scheduler on Unix-like operating systems. To add a task, you invoke it with the cron tab -e command. The top line specifies command line interpreter to use. The rest represent jobs to run. Important! Cron is also the tool to use if you need to run commands at startup. A startup job starts with a attribute keyword followed by the command to execute. For example, this line will write current datetime to the timestamp txt file. Another really cool utility is screen. When you log in remotely, your terminal window is the place where the actual output of all programs you run takes place. Normally, if you close that window, these programs will also be terminated. The easiest way to get around this is use the screen program. Just type screen at the command prompt. That will open a virtual window where you can start any program you want. Then just type Ctrl-A, then B to disconnect from that window. The program you started will continue running even if you log off. To return to it, you just have to type the screen -r command. Naturally, screen allows to create multiple virtual windows with the help of the command line parameters. You can also start programs with screen at system startup and connect to them with screen -r later. And the last one, LSUSB. This small utility lists all your USB devices along with their hardware IDs. That would be it for today. Thank you very much for watching, and I'd really love to hear what you think. Please feel free to like or dislike if you wish, and don't forget to comment and share and subscribe. This was Ron Mattino. Be good.